Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 7, Lesson 5 on factoring challenging trinomials. Let's get right into this, given that we've already learned multiple ways of factoring including GCF, difference of perfect squares, factoring simple trinomials, and also factoring by grouping. Today we'll look at the hardest type of factoring, at least that we'll see in this course, which is known as factoring challenging trinomials. I can't even say it, that's how challenging it is. All right, but first, let's talk about factoring by grouping, and let's review how to do that from the last lesson. You've only factored trinomials with a leading coefficient equal to 1. These are really relatively simple because you only have to find two numbers that have a particular sum, right, and a particular product. Those with leading coefficients other than 1 are more challenging to factor. There is a method to do so that uses or using factoring by grouping. So before we really kind of get into the method of factoring challenging trinomials, let's review how to factor by grouping. Exercise number 1. Write each of the following expressions as the product of two binomials. Now, the first one should be very easy, and the second one you actually have to do the factoring by grouping. The first one already has the sort of like preliminary steps of that done. So what I'd like you to do is pause the video now and go ahead and do both of those. Now, if you don't know how to do letter B yet, then this is not the lesson for you. You need to know how to do factoring by grouping before you do this lesson. All right, so if you're like, I have no idea what he means by factoring by grouping, go back, look at our previous video, learn that technique, and then rejoin us. But in letter A, for those of you who have studied factoring by grouping, here we notice that we have a common binomial factor of x minus 5. So we factor that out, and we have x minus 5 times 4x minus 3. That one was simple. Letter B, we have to do a little bit more work, but remember, our initial step is to group the first two terms together, and then group the second two terms together. The first two terms, we note we can factor a 6x out of both of those, and those will leave me with 6x times 2x minus 1. And the second two terms, we can factor just a 7 out of. That also leaves me with 2x minus 1. We're now sitting at a situation that looks very similar to letter A in that we have this common binomial factor that we can pull out of both. So that'll be 2x minus 1 times 6x plus 7. All right. Now, if you can do this, you can factor challenging trinomials. So let's take a look at how that's done. Here we go. We're going to call this the AC method. All right, a lot of math teachers call it the AC method. You won't probably see that piece of terminology on like a state exam or anything like that, but we'll call it that for now. The next exercise, we will see how to use what's known as the AC method of factoring in a relatively simple example to factor a trinomial with a leading coefficient other than 1. So this is really key, leading coefficient other than 1. By the way, the method that we're going to use will work even if there's a leading coefficient of 1. Okay, so it even works in the simple case, but you probably wouldn't really need it. Let's take a look at exercise number 2. Consider the trinomial 4x squared plus 5x minus 6, which is written in the form ax squared plus bx plus c. Letter A, find the product of a and c, then find two numbers whose sum is equal to b and whose product is equal to a times c. Now again, I want you to remember that when we factored simple trinomials, what we were always doing was looking for two numbers whose sum was simply that and whose product was that. Now we're going to do something a little bit different. The first thing we're going to do is actually find the product of these two numbers. So I don't want a product anymore of -6. I want a product of 4 times -6, which is -24. Thankfully, the sum, though, is still just that linear coefficient of 5. So again, the big difference between factoring challenging trinomials and factoring easy ones is that when we factored the easy ones, we were just looking for a product of equal to that and a sum equal to this. Now we're looking for a product that's equal to the product of those two numbers and a sum equal to that. So what two numbers have a product of -24 and a sum of 5? Well, those two numbers happen to be 8 and -3. right? So 8 plus negative 3 is positive 5, and 8 times negative 3 is negative 24. All right, let's keep going. Rewrite the trinomial by breaking its linear term, 5x, using the two numbers you found in A. In other words, we're going to creatively rewrite this trinomial in an equivalent expression by writing it as 4x squared plus 8x minus 3x minus 6. All I've done is taken the 5x and rewritten it as 8x minus 3x. Now you might say, why didn't you write it as negative 3x plus 8x? Totally could have. It doesn't matter. It doesn't matter whether I write it as 8x minus 3x or minus 3x plus 8x. It's going to work out the same either way. It doesn't matter. All right, but the beautiful thing is we can now factor this by grouping. Let's take a look at that in letter C. Factor the trinomial from B using factoring by grouping. All right, cool. Well, this is almost identical to exercise 1, letter B. So I'd like you to take this thing and factor it by grouping. Pause the video now and go ahead and do that. All right, let's do it. Now remember, that expression, 4x squared plus 8x minus 3x minus 6, might as well bring it down here anyway, that expression is equivalent to our original trinomial. We just rewrote the 5x as 8x minus 3x. I'm now going to factor this by grouping the first two terms together, and by grouping the second two terms together. The first two terms I can factor a 4x out of, leaving me with a 2x, I'm sorry, not with a 2x, leaving me with an x plus 2. Now remember, with factoring by grouping, whatever I factor out of here, I really want to get an x plus 2 again. I'm going to need to factor a negative 3 out in order to do that, but I will get an x plus 2. So I can factor a 4x out of here, leaving me with 4x times x plus 2. I can factor a negative 3 out of both of these two and be also left with an x plus 2. So at the end of the day, I then have x plus 2 times 4x minus 3. And we just factored a challenging trinomial. And what we really did is we kind of combined the techniques of factoring a simple trinomial by using product and sum. The big difference is that I have to find the product of A and C and the sum of just that B term, right? I then break that linear term using these two numbers, and then once I do, I will always be able to then factor this by grouping, assuming I can find these two numbers. If these two numbers don't exist, right? If they don't exist, then this trinomial cannot be factored. It's prime. Okay? Now, we want to feel confident that we actually have it correct. Let's take a look at letter D. Check that the factoring is correct by multiplying the two binomials to ensure their product is the original trinomial. So remember, right, the original trinomial was 4x squared plus 5x minus 6, right? That was our original trinomial, right? Let's actually multiply these two together just to ensure that we've got it right. So I just want to make sure that when I multiply these two things out, I in fact do get this. If not, then I've done it incorrectly. All right, so I'm going to use the foiling method. X times 4x is 4x squared. X times negative 3 is negative 3x. 2 times 4x is 8x. And 2 times negative 3 is negative 6. And before I go on, right, notice already, right, negative 3x and 8x, negative 3x and 8x, 4x squared, negative 6, right? I'm really actually kind of going back in reverse, right? I've now split apart that 5x, into the negative 3x and the 4x, etc. These two will combine into that positive 5x, and then I've got my negative 6. And that's it, right? So factoring challenging trinomials, ones where the leading coefficient is not 1 and it's also not a GCF, so you can't just factor it out and be left with an easy trinomial. In those situations, we simply have to do the product sum, but the product's a little bit different, and then we have to use factoring by grouping. All right, let's kind of get into this and see how it's really done. The AC method of factoring trinomials is extremely effective, but still requires the student to find two numbers that allow us to split the linear term of the trinomial in a helpful way. Sometimes these can be easy, other times it is much more challenging. So let's play around with another one just to make sure that we've kind of got this idea. Exercise number 3. Consider the trinomial 6x squared plus 19x plus 10. Factor this trinomial using the AC method. Check to ensure you factored correctly. Now keep in mind that if you are on an exam or something like that, they're not going to say use the AC method. They're just going to say factor this completely. So the first thing I would want to ensure is that the 6 isn't just some GCF I could factor out. Now, if I look at 6, 19, and 10, the 6 is most certainly not a common factor, okay? So what I want you to do is pause the video now and see if you can reproduce what we did in the last exercise. And if you're still confused, that's fine. Pause the video for a moment, take a little shot at it, come back. We're obviously going to go through it. So go ahead and take a few minutes. All right, so first thing I want to do is I want to find the product of 6 and 10. Right, so 6 times 10, and that's 60. I want a sum that's equal to 19, right? So I'm looking for two numbers whose product is 60 and whose sum is 19. And they're not 6 and 10 because 6 times 6 plus 10 is 16 and I need 19, right? It would be great if it were just these two numbers again, but it's very rare that that will ever happen. All right, so I'm thinking about product of 60, right? So that's, 2 times 30, it's 3 times 20, it's 4 times 15, it's 5 times 12, it's 6 times 10, etc. Right? And by the way, right, I know both numbers are positive because they have a positive product and a positive sum. Obviously, 2 plus 30 is not 19, 3 plus 20 is not 19, 4 plus 15, there it is. Right? There are my two numbers. So my two numbers are 4 and 15. All right, so now what I'm going to do is I'm going to take my trinomial 6x squared, and that 19x, what I'm going to do is I'm going to write that as 15x plus 4x plus 10. So all I'm doing is splitting that 19x into a 4x and a 15x. And again, if you did 6x squared plus 4x plus 15x plus 10, it's great. I almost hope you did, because then you'll see that you'll get exactly the same answer either way. Now, I'm going to factor by grouping. I'm going to group these two together and these two together. From these two, I can extract a 3x, so that's going to be 3x times 2x plus 5. And from these two, I can factor out a 2, and that's going to leave me with 2x plus 5. If I'm doing this technique correctly, I should get a common binomial factor right there, which I do. And there is my final answer. Okay. Now the problem does say check to ensure you've factored correctly, right? And to check, what you would do is you would FOIL these back out. You'd do 2x times 3x, giving me 6x squared, 5 times 3x plus 2 times 2x, 5 times 2, etc. We're going to skip the check, just for the sake of time in this video. All right? But that's it. It's really cool. Now, as I said, sometimes the numbers are easy to find, sometimes they're harder to find. Let's talk about what would happen if a GCF is involved. As with all factoring, care should be taken if you're asked to factor completely, as a greatest common factor may be present. Let's see exactly what happens when a GCF shows up in one of these types of problems. Exercise number 4. Consider the trinomial 6x squared minus 33x plus 36. Letter A. What product must you use to split apart the linear term of this trinomial? Why does it make this problem difficult? All right, so if you're just going into this, right, and you're thinking, I need to factor this thing completely, right? The first thing that you would do is you would do this. You'd say, well, I've got a product equal to 6 times 36, and I don't know about you, off the top of my head, I don't really know what that is. So, I take my calculator out and I find that it's 216, right? Now, that's just, I would have to find two numbers that have a product of 216 and a sum of negative 33, right? And the reason that that's going to be difficult is that 216 is, maybe I'll put it like this, is rather large, right? So in other words, to actually have to sit there and go, wow, okay, well, I need two numbers that multiply to be 216 and then add to be negative 33, that's pretty challenging, right? That's tough. I can maybe do it. I'd have to sit with a calculator. Even I would have to sit, kind of plug in numbers on the calculator, but I think I could eventually find them. But I'm going to tell you what they are anyway. Letter B. Show that the two numbers needed for A would be negative 9 and negative 24. Well, okay, that's easy enough. Let's do this together. Negative 9 times negative 24, right? I could literally just grab my calculator and maybe put in a new page or calculator, and hey, negative 9 times negative 24 is, hey, 216. And then obviously negative 9 plus negative 24 is negative 33. So those are the two numbers. But that might be a little bit tough to really come up with the fact that the two numbers are 9 and 24. And to be clear, negative 9 and negative 24. All right, but since I told them to you, might as well use them. Let's take a look at letter C. Using the numbers from B, factor this trinomial using the AC method. All right, well, why don't you go ahead and do it? That's actually not that difficult. Why don't you take the negative 9 and the negative 24, break up the negative 33 using those two numbers, and then go ahead and factor it by grouping. All right, so what do we have? Well, we can rewrite this as 6x squared minus 24x minus 9x plus 36, okay? I can group it kind of like this, put a plus there. The first two I can factor by taking a 6x out. That'll leave me with x minus 4. And the second one I can factor, remember I gotta have that x minus 4, so I'm gonna factor a negative 9 out, and that will leave me with x minus 4. And so all of this will be 6x minus 9 times x minus 4. All right, now very important, let's take a look at letter D. Why is your answer from C not factored completely? Finish factoring it. All right, so I want you to really take a look at this and see if you can think about why this is actually not factored completely. Pause the video now and consider that. Well, the x minus 4 is completely okay. But the 6x minus 9, both the 6 and the 9 contain a common factor of 3. And therefore, 6x minus 9 is not fully factored. Right? It's not fully factored. You can extract a 3 out of it. In fact, right, if I factor this now, I can now write this as 3 times 2x minus 3 times x minus 4. And all I'm doing is rewriting the 6x minus 9 as what it's equivalent to, 3 times 2x minus 3. Now, why is there that GCF? Well, there's that GCF because if I look at the original trinomial, 6x squared minus 33x plus 36, that trinomial has a GCF of 3. So let's now factor this in a slightly different way. Letter E. Now, try the AC method, but first factor out the GCF of the trinomial. What are the advantages of factoring out the GCF first? All right, so let's go through this together, right? The first thing I should always be looking for is a GCF. Whether they tell me to factor completely or not, I should look for it. And when I look at the number 6, 33, and 36, it should occur to me that all three of those are divisible by 3. So the first thing I can do in this problem is I can write this as 3 times 2x squared minus 11x plus 12. All right, 3 times 2x squared minus 11x plus 12. Now, right, now I want to think about how to factor this. So I look at this thing and I go, oh, okay, I want two numbers that have a product equal to positive 24 and have a sum equal to negative 11. Now you might be saying, well, what about the 3? Don't worry about the 3. Do you know what I mean? If I were factoring the number 12 completely and I wrote it as 3 times 4, right? You know, and I said, well, okay, I need to keep factoring that because 4 can be broken down further. I don't have to worry about the 3. I would just say, well, that's 3 times 2 times 2, right? Same thing here. I need to just be thinking about this. So I'm looking for two numbers whose product is 24 and whose sum is negative 11. And if you need to, write the 3 off to the side. Just don't forget to bring it back at the end, right? And those two numbers, let me just erase this. Those two numbers are going to be negative 3 and negative 8, right? Negative 3 times negative 8 is positive 24, and negative 3 plus negative 8 is negative 11. All right, so I can now write this as 3 times 2x squared minus 8x minus 3x plus 12. All right, we're going to have a lot of parentheses here, but you'll live with it. All right, we've got 2x squared minus 8x. I'm going to group those together. Plus negative 3x plus 12. I'm going to group those together. We're going to extend the page a little bit so we have a little more room. I'm not going to drop that 3. From these two, I can pull out a 2x times x minus 4. From these two, I can pull out a negative 3 times x minus 4. Don't lose that 3. Then I've got this common binomial factor of x minus 4, and then times 2x minus 3. And if I've done everything correctly, when I go up here, I see exactly the same answer. Now you might be like, that's not exactly the same answer. But it really is, right? The only thing that's different between these two answers is the fact that the x minus 4 and the 2x minus 3 are in that different order, but multiplication is commutative, so it doesn't matter. All right, now, without writing all this stuff down, what are the advantages of factoring out the GCF first, right? Well, one of the advantages is by the time we get down to the factoring by grouping, we're ensured that there will be no GCF in these two. That's advantage number 1. But the second, and I think much larger advantage, is after I've factored that 3 out, now I'm looking for two numbers whose product is 24 and whose sum is negative 11. The numbers are much smaller, right? As opposed to up here, I'm looking for two numbers whose product is 216 and whose sum is negative 33. Much larger numbers, much worse to deal with, right? Because they're just larger. You know, the 6 and the times 36 is much, much larger than the 2 times the 12. That's because there's been a 3 taken out of both of them as a factor, and that ultimately is actually taking out a 9, believe it or not. All right, that being said, let's get a little bit more practice. Additional practice, exercise number 5. Gain additional practice factoring using the AC method with the two trinomials below. Make sure to factor each trinomial completely. All right, so what I want you to do is I want you to actually take a shot at both of these. And the first question I want you to ask yourself is there a GCF of the trinomial? And if there is, my advice is to factor it out first. You don't have to, as we saw in the last problem, but my advice is to do so. If there isn't a GCF, right, then just go for it. Just go ahead and do it. But if there is, factor that GCF out first. Anyway, pause the video now and actually try to work on both of these, try to work them out, and then we'll go through both. Well, both of these problems have a leading coefficient of 4, and I did that by design. The first one, I look at 4, 17, and 15. There is no GCF there. All right, no GCF at all. So I launch immediately into product and sum thinking, right? And I'm looking for two numbers that have a product equal to negative 60 and have a sum equal to negative 17. All right, those two numbers end up being 3 and 20, where the 20 is negative, right? 3 times negative 20 gives me negative 60, and 3 plus negative 20 gives me negative 17. I now can take my trinomial and I can write it as 4x squared. Here, I'll even do this, plus 3x minus 20x minus 15. Again, the 3x and the 20x can be flip-flopped. I can then write this as 4x squared plus 3x plus negative 20x minus 15. From the first set of parentheses, the only thing I can factor out is an x. That will leave me with 4x plus 3. In the second parentheses, you've seen this time and time again, I'm going to factor out a negative 5, which leaves me with 4x plus 3 again. I need to have these two be the same or I'm out of luck, but they are the same. So I get 4x plus 3 times x minus 5. All right, excellent. Let's take a look at letter B. 4x squared minus 30x minus 16. Now in this one, I look at the 4, I look at the 30, I look at the 16. They're all even, so at worst case scenario, I can at least pull a 2 out, and that's actually the best I can do here. I can't pull a 4 out, but I can factor a 2 out. And when I factor that 2 out, I'll be left with 2x squared minus 15x minus 8. Fantastic, right? Then I'm going to look within the parentheses. I'm looking for a product equal to negative 16 and a sum equal to negative 15. And that's kind of cool because that actually ends up being the numbers negative 16 and positive 1. That's a little bit rare when we have one of those pairings, but it's true, right? Negative 16 times positive 1 is negative 16, and negative 16 plus positive 1 is negative 15. Now it becomes our parentheses nightmare, especially if you kind of carry that 2 all the way along. So I'm going to say 2 times 2x squared minus 16x plus x minus 8. All right, that's going to be then grouping 2x squared minus 16x plus x minus 8. From this first set of parentheses, I can pull out a 2x. That'll leave me with x minus 8. Now it's kind of interesting. The second set of parentheses, I really can't pull anything out, but I'm going to write it as 1 times x minus 8, right? And this is kind of key, right? I have that x minus 8 there. I've got the x minus 8 there, but if I'm going to factor that x minus 8 out, I have to think about what it's multiplying by, and it's, in this case, multiplying by the number 1. So now I'll have 2 times x minus 8 times 2x plus 1. And that's it. All right, and now we know how to factor challenging trinomials. Let's put a wrap on this. All right, believe it or not, we've basically seen all the factoring techniques that we're going to see in Algebra 2, right? That's GCF factoring, it's difference of perfect squares factoring, factoring of simple trinomials using products and sums, factoring by grouping, and then factoring challenging trinomials by both using our product sum work and factoring by grouping. All right. Now, why factoring by grouping works with factoring challenging trinomials, especially given that AC thing, is a little bit beyond our course. It gets very symbolic, you know, and it's actually more confusing than what is worth. But it is a fantastic technique that really allows you to factor any trinomial that is not prime, right? Any trinomial that can be factored, one can do it with this particular method, which is kind of great. And we're going to be seeing this method consistently throughout this course, so make sure that you really get good at it. For now, I just want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.